In this video, we're going to talk about the four major layers of Earth's atmosphere and how things like air pressure and temperature change within each layer. In this chapter, we're going to talk a lot about air pressure and altitude. So air pressure is just the amount of weight of all of the air above it. And we see that air pressure changes with altitude. Altitude is our elevation above sea level. Generally, it's going to be the height within our atmosphere. So if we're starting off at the surface of the Earth, our altitude is going to increase as we move higher and higher above our planet. But we see that the weight of the air pressure changes with our altitude. As we start increasing our altitude or getting higher in our atmosphere, air pressure starts to decrease. At sea level, the average air pressure on our planet is 1,000 millibars. You might be more familiar with an air pressure system called PSI, or pounds per square inch. This is how we measure the air pressure in our car's tires. So our average air pressure would be 14.7 PSI on this scale. But if we are above sea level, as we start increasing our altitude higher and higher, our air pressure is going to continue decreasing. And overall, we see that 90% of our atmosphere, or 90% of all of the air around our planet, is below 10 miles in height above the surface of our planet. And when we look at our atmosphere, we're going to be able to break it into 4 different layers. Be careful here because depending on your source, they're going to have differing numbers and differing names for the layers. So we're going to stick with our textbook for this. If you look at other websites or YouTube, you might see slightly different names or terms for these. But for this class, let's focus on our textbook terminology where we have 4 layers. Our troposphere, our stratosphere, mesosphere, and thermosphere. We're going to start off with the troposphere, which is the layer closest to the surface of the Earth, and then we're going to go layer by layer, working our way towards outer space. But the first, lowermost layer of our atmosphere is called the troposphere. With this, the average height above the surface is roughly about 7 miles above the surface, but it does change in thickness in different locations of the Earth. But when we get to the top of the troposphere, we're going to have an outer boundary. It's going to very drastically get different in conditions above this boundary. So we call this outer boundary the tropopause. It's just separating the troposphere from the layer above it. And when we're looking at our air pressure in the troposphere, we're going to see that it's going to decrease as we increase our altitude. As we get higher and higher above the surface of the Earth, our air pressure will decrease. And in this layer, the temperature decreases as well. And this is because the surface where we live is absorbing a lot of heat and radiation from the sun. So it's going to be really hot in comparison to all the gases that sit above it. So our troposphere, as we get farther away from that hot surface, is just going to start getting cooler and cooler with increasing altitude. So in this layer, we see something that's called the environmental lapse rate. As we get 1,000 feet higher within the troposphere, the temperature decreases 5.5 degrees Fahrenheit. So every 1,000 feet higher in the troposphere, it's going to decrease the specific amount in temperature. And this photo is just a really good image of this. At the top of our mountain, we see that there's lots of snow and ice because it's at a higher altitude above sea level. It's going to be colder and the air pressure is going to be lower. But down here at the base of the mountains, we're looking at grasslands. It's going to be a lot warmer because it's closer to Earth's surface where it's absorbing all of that sunlight. So how do we know that it's 5.5 degree decrease as we're increasing our altitude in the troposphere? We do this through something that's called a weather balloon. The weather balloon is fairly simple. It's just a gigantic balloon that we fill with gas. But we attach an instrument called a radiosonde to this balloon. So as the balloon starts to rise through the atmosphere, it's going to cause this radiosonde to rise with it. As it's rising through the air, it's going to record different conditions, like the air temperature and humidity, what kind of precipitation is occurring. And it's going to transmit all of that data through a radio back to whomever released it. Using this, we've been able to figure out exactly how our temperature decreases in the troposphere. But in addition to the troposphere, we have those 3 other layers of our atmosphere on top of it. So as we continue working our way towards outer space, above the troposphere, we're going to have the stratosphere. And here in the stratosphere, we're going to see that the temperature remains pretty constant until about 12 miles above the surface. But in this layer, we're going to see the exact opposite of the troposphere. We're going to see that the temperature is actually going to increase or get hotter as we get farther and farther from the surface within the stratosphere. And that's because this is the layer of our atmosphere that has the ozone layer. Ozone is absorbing harmful UV radiation in this layer. So instead of letting all of that heat and dangerous radiation go towards the surface, it's all absorbed by ozone here. Because it's absorbing radiation, it's getting hot. So as we increase our altitude in the stratosphere, the temperature increases. But as we get to the top of our stratosphere, we're going to have yet another pause or boundary between the layers. And the boundary at the top of the stratosphere is called the stratopause. Above the stratosphere, our next and our 3rd layer is called the mesosphere. With this one, there's nothing really special about this one. There aren't any gases collecting or releasing heat. So as we increase our altitude in the mesosphere, we again decrease temperature. So in our atmosphere, we see that it decreases in 2 layers. In the troposphere, where it's getting farther from our warm surface, and in the mesosphere, where it's not special or really doing anything. At the very top of our mesosphere, we have another pause or boundary, which is called our mesopause. And then above our mesosphere, we have our last layer, our thermosphere. There is no pause at the top of the thermosphere because it doesn't have an outer limit. It just gradually fades into outer space. So this thermosphere has very little mass to it. All of the air is under such little pressure, it's just really widely spread out. But here, because the gas molecules are so far away from each other, they're going to be capable of moving at higher speeds. And with a thermosphere, there's nothing protecting it from the sun. So we see that our thermosphere is the hottest layer in our atmosphere. It's the first layer that sun interacts with. So we have cooling with altitude in the troposphere and mesosphere, but we have warming with altitude in the stratosphere and the thermosphere. The stratosphere has that warming ozone layer in it, and the thermosphere is just the first layer that sun hits as it's moving through our atmosphere.